the b, a is that coefficient, right? A needs to be a real number. Okay, so basically what it comes down to,
Can't be an I.
no i's. Yep. Okay, and b is or your exponent is a rational number. Okay, fraction, whole number. Okay.
So what's the mean by rational? Or we can back.
Basically what it comes down to is a whole number, or it's going to be a decimal that stops.
I.
Okay,
So knowing items,
what's that?
so knowing items or whatever.
Okay,
So 1/3 is not a rational.
1/3 is. Because one, I'll get back there now. I gotta double check. Okay, so we got f of x plus g of x. Okay, if f of x is 3x to the 1/3, g of x is 2x to the 1/3, we're just replacing f of x with f of x, g of x with g of x. Okay, so that's saying 3x to the 1/3 plus 2x to the 1/3, and we did these already, right? Now it's just a matter of plugging in your f of x into f of x, g of x into g of x. Can I add those? Are they like terms?
Yeah.
X to the 1/3, x to the 1/3, right? Okay, so that tells us we add the coefficients, correct? 3 plus 2 will get 5. Do I do anything with those exponents?
No.
Oh, yes. Did you start that?
Yeah,
Oh, perfect. Thank you, Clyde.
no problem.
5x to the 1/3. So just replacing those functions with what they are. Okay, so f of x minus g of x, 3x to the 1/3, minus that 2x to the 1/3. Okay. We're still dealing with the same functions and they were like terms before, right? They're still like terms. Now you are just subtracting, which would give me
X, 1 to the 3rd.
x to the 1/3. Okay. Questions on those? Okay, f of x times g of x. F of x is 4x to the 1/3. G of x is at x to the 1/2. Okay, when you multiply these things, okay, you multiply your coefficients, right? 4 times 1, so just 4. And when I multiply two things that have the same base, what do I do with those exponents? Add. So 1/3 plus 1/2. What's that common denominator?
6.
6. 1/3 with the denominator 6 would be
Not 6.
2 6
I thought you were asking for the funding.
plus that 3 6, which will give me a total of that 5 6. Okay. Okay, f of x over g of x now, that same division, correct? Just replacing f of x with f of x, replace g of x with g of x. Now what am I going to do with those exponents of x?
Subtract.
Subtract. And we know we're going to have that common denominator, right? That 1/3 was 2 6 minus 3 6.
-1 6.
So negative 1 6.
And then you bring that to the denominator.
We got to bring that to the denominator. Now, do I bring that 4 with it?
No.
So remember, that's like saying 4 to the first times x to the negative 1 6, right? Only the x has the negative exponent. So the common mistake I'll see on these ones is this,
Which is wrong.
which is wrong. Okay? Only the x is being taken to that negative exponent, so the 4 stays on top, and the x will go to the bottom. Alright. So nothing really too new with those ones. Something new that you guys should never have seen though. Composition.
What?
Composition of functions. Okay, composition of function f with the function g. Okay, this is how you will see it. F of g of x. Okay, everything you guys have done up to this point, say you had a function and it'd say f of 2. Right? F of 2 would say you take 2 and you plug it into the function, correct? So f of g of x, that's saying you're going to take a function
Of a function.
and plug it into a function. Okay? It's still the same idea, it's just going to be an expression now instead of just a number. Okay, domain, we'll talk about that here at the end. Now, watch the order. Okay? F of g of x is not the same as g of f of x. Okay? So make sure you watch the order. So, like when I say f of g of x, what's g of x?
X squared minus.
Okay, so again, you're used to just seeing f of 2 and you'd plug 2 into there, correct?
Yeah.
Now instead of 2, we're going to plug in x squared minus 1. So g of x, you're going to take g of x and replace x with,
X
X
squared minus 1.
yeah. So we got 2 over x, and we said we're replacing x with that x squared minus 1. Sometimes you have simplifying, sometimes you don't. In this case, we don't. Okay. So g of f of x then, that's saying g of f of x, which is 2 over x. So I'm going to take 2 over x and plug that into x, correct? So one thing I like to have you guys do, okay, this is where x would go, right? You square that minus 1. What am I replacing x with?
2 over x.
2 over x.
That's 4 over x squared, right?
Would be, yeah. Question?
Hold on.
I'm just lost.
Okay.
What?
Already?
Okay.
Yeah.
Andrew.
Sorry, that was hard. That was me. Sorry.
Which page is this?
This is the 7.3a. And it's about 3 or 4 slides down. Okay. F of x. Do you agree f of x is 2 over x?
Yeah.
Okay. So it's saying I'm taking that f of x and I'm going to plug it into g. So here's f of x. And I'm replacing the x with 2 over x. Okay. So just imagine. Okay. That looks similar to g of x there, right?
Yeah.
Okay. This is where x would go, but what am I replacing with x?
Oh.
F of x, which is 2 over x. Okay. Then we can simplify that, right? The quotient to a power, we take that exponent to both terms. 2 squared over x squared, which would be,
Oh, x squared minus 1.
okay. Okay, f of f of x.
That's 2 over 2 over 1. Or not 1, x.
So that's saying f of 2 over x. That's saying I'm going to replace this part with 2 over x, correct? So what this one comes down to is you're taking this function and plugging it back into itself. So 2 over x, right? I'm just going to replace that x with the parentheses. What am I replacing x with?
2
2 over x. Now, do you think I want you to leave it as a complex fraction like that?
No.
No. So one thing I think makes things easier for you guys to see, I can write 2 as 2 over 1, correct? And a fraction bar is just division. In dividing fractions, you are multiplying by the, so 2 over 1 times the reciprocal of that 2 over x, which is x over 2, correct? So 2x over 2, which is
And you can divide, which is just x.
x.
So if there's a fraction in the denominator of a fraction, you can essentially just take the denominator of the bottom fraction and bring it to the numerator of the whole fraction. Alright.
It's just thinking when you multiply by the reciprocal, you're just bringing the denominator to the top then, right?
Yeah, I just cut the whole thing here, but that's a fraction, you can bring the denominator to the numerator.
Okay. Now, any question, bud?
No, I'm just trying to process all this, like,
Yeah, or is it the f of fx, f of x one that you're looking at?
yeah,
Okay. Okay, so f of x is 2 over x, right?
yeah,
Okay, and if I say f of x, we're taking f of x and plugging it into itself. So, if I was to get rid of that, 2 over x, right? So I just replaced x with the parentheses. What am I replacing x with?
f of x,
Which was
2 over x,
2 over x. So I'm just going to put 2 over x into that parentheses. But then that's a complex fraction, right?
now I see.
Okay, and then we just got to simplify that complex fraction.
This is surprisingly simple.
All right, now let's look at domains of these compositions now. Okay, when you look at the domains, okay, domain again. Domain is the x values that we can plug in and get something back, correct? Now, when it comes to these, it's not a matter of just looking at the final result. Okay, what you have to do is you have to look at the domain of whatever was inside the parentheses and the final result. Okay, so in this first one, g of x was on the inside, right? The domain of g of x, x squared minus 1, is there anything I cannot plug in there?
Yes. Wait, no, never mind. X, 1 minus 1 is just 0. No, you're fine.
So the only time we've really had restrictions was when there's a variable in the denominator so far, right? Okay. Do we have a denominator at all?
Not in G, no.
No. So we can include everything, correct? Okay. But then now we have to look at f of g of x as well. So our result. Do we have a variable in the denominator there? Yep. Okay. So we cannot divide by what value?
2.
0.
0.
So if there's that variable in the denominator, you'll take that and set that equal to 0, correct? And then solve. So x squared equals 1. You square root that. X is equal to
1.
just 1? Plus or minus. So the domain for that composition was I can include everything except for plus or minus 1, right? Okay. So then, when you do the overall domain of this composition then, you have to take the most restrictive. Okay. There was no restrictions with g of x, right? So we don't even have to worry about that. There was restrictions with the result though, correct? So that is what we're going to do. So let's say like in g of x, x could not equal 2. Just imagine, say x cannot equal 2. Your restriction would be x cannot equal plus or minus 1 and also 2. Okay, so when I do this, I do my restrictions with that, and then if the result restricts it further, I add those restrictions. You guys follow me on that? Okay, so on this one, the two values we couldn't include were plus or minus 1, just Isaac 7.3 worksheet, okay, for homework. Okay. So now when I did g of f of x, we got to figure out f of x and then g and the result, correct? F of x
That's the exact same.
for f of x.
Yeah, we've already gone through that.
Have we?
Yeah. It might as well have.
We got x in the denominator. Set it equal to 0, right? Do you have any solving to do? No, it's just x cannot equal 0, correct?
Oh, wait, I'm done.
Okay, so then our result here, we have a variable in the denominator. You said x squared equal to 0, x is still just equal to 1. Square root of 0 is 0, right? So, you ended up with your inside function as x cannot equal 0, and your result as x cannot equal 0. So the overall domain is just going to be x cannot equal 0. All right, so then on this one, f of x, we already figured out that domain, right? We said x cannot equal 0. Now on f of x, on the result, our result was just x, right?
Yeah.
Does x have any restrictions?
Well,
Nope. Okay, so this one, what would the domain be there?
x er such as that x is not equal to 0 because, the first one.
Okay. So on this one, this really emphasizes, okay, I look at my result, that has no restrictions, right?
But the input does.
Exactly. Our input did, correct? Okay, so it's not a matter of just looking at the result and looking at that domain. Okay, you have to look at your input, whatever's inside the parentheses, because if there's a restriction there, that means like f of x, I couldn't plug in 0. So 0 will never be able to get plugged in. Okay, and then the result, okay, if that restricts it further, then you can't plug that in as well. Okay. All right, so homework on that one. 7.3 homework back. 13 questions. For some reason, Word is weird when I bring stuff into OneNote. So if you see a box like that, it's multiplication. Okay? All right. Any questions on homework before I give you guys the quiz?
Can you go over some of these?
Yep. Oh, let's go over those ones that were at the beginning. Okay, so if we got things in radical form like this, what's the thing that needs to be the same in order to actually do something? Index, right? 2 and 2. So we're good there. And that means I can actually multiply, correct? Okay, so I'm looking at my numbers, 1 times 2. It's gonna be 2. X times no other x, correct? So just x. Y times y cubed would give me y to the 4th. And z times z to the 4th will give me z to the 5th. After you do that multiplication, we gotta make sure there's no perfect squares in there though, right? Basically, if it simplifies, we need to simplify. Y, yep. Nothing's gonna come out with the 2, nothing with x, right? How many y's come out? Okay, so y squared. So remember, power divided by index, right? 4 divided by 2, 2. No remainder. So that stays, there's nothing left on the inside. How about z?
Z squared,
Z squared will come out,
Z, 1 Z inside.
and 1 z inside, correct? 5 divided by 2, that's going to be 2 remainder 1. Do we got to worry about even, odd in there at all? Oh, because the resulting ones are all even, right?
Where is this?
This is just at the top of 7.3, the notes we just took. Okay? So when it comes to simplifying radicals again, can't have a fraction inside the radical, right? Okay. So how did we take care of those? Split it up. And let's just simplify what we can. Square root of 9,
3.
square root of x squared,
X.
and that y is going to stay inside, correct? 32, 2, 16, 2, 8, 2, 4, 2, 2, group of 2, group of 2. So 4 would come out, 2 times 2, right? Z will also come out, square root of 2z.
I don't think we're supposed to have a square root denominator.
So we still got further to go, right? So I'm going to have to multiply both top and bottom by square root of something, correct? And it would be 2z. Okay, that's a nice thing about square roots. You get the radical in the denominator, it's a square root. You literally just multiply by that same exact radical. I'm going to get the cube and fourth root, so we'll do one of those. Inside? Yep. Okay, because we didn't have any coefficients, right? So that 3x stays. And then 2zy, yep. Over 4z times
2z.
2z. Square root of 2z times square root of 2z is just 2z, correct? Can't forget about our 4z in front though. Then we got 3x square root of 2yz, technically. Doesn't matter.
Could it be 8z squared?
And it's 8z squared. Nothing simplifies past that. Okay. You guys want to do 7 point, like what, well, let's just do that. Any specific questions? More than a square root? Okay. So on here, can't have that fraction inside the radical, correct? So we'll split it up. Cube root of x cubed. Cube root of y squared, correct? This is on the homework one.
Just the way I hate teleportation.
Okay, is there anything we can simplify?
Just worrying.
Yes.
Cube root of x cubed is just x. But I still need to simplify that, don't I?
Multiply
Now-
the top and the bottom by the third root of y.
Because you only need one more y to complete it.
Okay. So we're gonna have to multiply by cube root, right? And if I'm doing a cube root, I need a perfect cube, right? If I have two y's already, how many more y's do I need? I just need one more. So then x cube root of y, and what's the cube root of y cubed? Y. Okay. That's the nice thing about square roots, right? So if I just multiply by the same thing, it makes it a perfect square. Cube roots, you gotta figure out what's gonna make it a perfect
So
square.
that's what basically what we do with square roots, is just we don't talk about it, is it just the form?
Yeah, exactly. Okay, let's do this one. Okay, radical form, right? We gotta look to see, are the indexes the same?
No.
Since the indexes aren't the same, I can't do anything in radical form, right? Okay,
You gotta do the fraction.
so we gotta change it into exponential form, correct? X to the,
Don't we just say the
Five
fractional
over
form?
3 over 5.
3/5.
3 over 5.
Index is always the denominator, right?
Sure.
Over x to the,
4 over 7.
now can I do something?
Yes, because the bases are the same.
Now the bases are the same, right?
Yeah.
And if it's a fraction, what do I do with those exponents?
You subtract.
You're so smart. Our brains together.
What's the common denominator?
35.
35. So 3/5, I'm gonna have to multiply top and bottom by 7, correct?
Yeah.
So 21 35 minus
20 over
20 over 35, which will give me x to the,
1/35. 1 over here. Oh my gosh.
now, suppose they ask you to write it in radical form.
Yeah, so 35 rows. Why? That's so dumb.
Because technically it starts in radical form, so the result should end up in radical form.
Okay, so.
It's come test or quiz time, just make sure to read the directions. I'll tell you which one I want.
Bottom, outside. Yeah. Okay, great.
Denominator's your index, numerator's the power.
That's just extra words. I just, yeah, like outside, yeah, inside over outside.
Okay, we just did that one.
So
So like on this one, that radical in the denominator is what's making it not simplified, right? What am I going to have to multiply top and bottom by? It's going to have to be cube root of something, correct? What's that? X squared. Because I have one x, right? I need two more. Over
X.
Oh, that was really fast. Okay, I see what you did. Okay, I was.
needed two more x's, right, to get rid of that
Yeah.
radical.
Yeah, got it. Yeah, she's so, I'm so low.
79. Okay, so let's simplify each term. Okay, I'm going to take this 1/3 to each part, right?
That's so hard.
What's a third of 9?
9 is 3.
1 times 1/3 is 1/3, right?
Yeah.
1 times 3, 1/9 times 3.
I don't know. 3 over 9. So the half. Or 1/3.
Are those like terms?
Yeah. Yes.
So 1 plus 1 will give me
2. Wait, where did you get 2 from? Oh, I see. Wait. No, I don't. Wait, how did you, why don't you have two y to the 1/3?
Is one, yeah, one, but then y also one?
So they're like terms, right? X cubed y to the third, x cubed y to the third.
Yeah.
Remember those don't change at all. You just add or subtract your coefficients.
Oh, cause they're multiplying, so, okay, I think I got, no, wait,
But why isn't it one, y to the third?
because they're together. They're not separate.
You're
They're in a
asking,
relationship.
oh,
I'm asking why isn't it like 2x to the third, 2y to the 1/3? That's the whole point.
like just on this part right here,
No, it should be the
Answer.
the answer.
I don't know.
Okay, you agree that x cubed y cubed third, x cubed y to the third, that's the same, right?
Yeah.
So that makes them like terms. And if they're like
It's just
terms,
a whole, it's not like two separate parts. Yeah, there you go.
yeah. So since they're like terms, I can combine them. Coefficients are 1 and 1, right?
Okay.
And so 1 plus 1, 2.
Yeah. Well, they don't give an explanation.
Okay, real quick, what would the answer to that one be?
Great question.
X plus X cube plus
Plus,
root 3, yeah.
Can I go any further than that?
is that just the answer?
That's just the answer.
Oh,
That's
crazy
so-
town.
Okay. Wait, but why can you have a radical in this? As an exponent?
Okay, it's just a number.
Wait, but like, I thought it wasn't.
Oh, okay.
Square root of 3 is just, it's
So we don't have.
1 point something something something.
Oh, I thought that was one of like our
It's an
laws.
irrational number and we just leave it at square root of 3.
Okay.
Alright, let's get everything on the ground.
Illegal to not do that.
Did you ever stop that?
Oh, right.
Oh.